So today we're going to start off with 3.7, which is the systems of inequalities. So what we're going to be doing is we're going to be graphing a bunch of lines in this, and then either shading above or below the line, depending on whether it says the y is greater than or less than the line. So on number 1, which I think maybe we did on Monday, but we'll just start there anyway. We have y is greater than x minus 4. So just like when you're graphing any line, you want the y by itself first, okay? Which it already is in this situation, right? The y is by itself. So we're actually going to graph this line. So before we get into it, we talked about this on Monday maybe. If you just have a less than or greater than, you are going to connect your dots or your points with a dashed line. If you are less than or equal to or greater than or equal to, you will connect it with a solid line. If you are greater than or greater than or equal to, you're going to shade above the line. That's where your y values would be greater than the line is above it. If you are less than or equal to, you're going to shade below the line because that is where the y values would be below the line. Okay, so let's just graph this one like we always do by making an XY chart and finding points to plot. So again, how would we do that? Go to your y equals on your calculator. And then you're going to type in this x minus 4. So again, there's your x, and then minus 4. And let's go ahead. You know how I like to always just graph it just to get an eye on what the graph is going to look like. So now I'm going to need 2 points, right? To tell Math Lab that I need 2 points. So I'm going to do second table to find 2 points. Again, you can graph any of these. So just choose 2 points to graph. So let's see, I'll do -1, -5. And I will do 0, -4. So if I am plotting those points, so this first point will be at -1, -5, which would tell me to go left 1 and down 5 to plot that point, right? Left 1, down 5. Oh, Anitra, you can't hear? Can everybody else hear?
I can hear you.
Okay.
Yes.
Anitra,
Yeah.
you may need to come down.
I can hear.
Turn on your
I can hear you. I
speakers.
have my audio on. I can hear you now. I have my audio on. I didn't hear
Okay.
audio.
Yeah, make sure your audio is on. This second point is at 0, -4, which would mean left and right 0, but down 1, 2, 3, 4. Then before I connect the points, I need to remind myself, is it going to be solid or dashed? Remember what tells you that. If it has the equal to bar, it's solid. If it doesn't have the equal to bar, then it'll be dashed. So this one would connect with a dashed line. And then you're going to shade either above or below the line. So remember, if yours says greater than, Or in other words, if your arrow points to the right, you're going to shade above the line. Okay, so I'm going to do a few of these, and then we'll do a couple in Math Lab also, just to go through how you turn the line from solid to dashed and how to do the shading also. Okay, let's look at number 2, because number 2 has a little bit of work we're going to have to do to it before we can do our points. (5x minus 3y) is less than or equal to -9. Now the first one was set up ready to graph because the y was already by itself. On this one, I'm going to have to solve it for y first, right? You have to get this y by itself. So a couple of things are going to happen during this process. So first of all, getting y by itself, first of all, get rid of the 5x. So I'm going to subtract the 5x. Let me get a better marker. If I do it to this side, I'm going to have to do it to this side. So on the left, the 5x is gone. I still have negative 3y. Drop down my less than or equal to. On the right side, I have those two terms separately, right? Because one's an x and one's not, so I can't put them together. So I just have those two terms separately over here. I've got a negative 5x and a minus 9. Still solving for y. Now, here's where something new happens. When I divide by -3, which is what I have to do to get that y by itself, there's my y by itself. Anytime you're working with an inequality, which means a less than or greater than problem, and you divide by a negative number, this symbol turns around. Okay, so since it started off pointing to the left, now it's going to point to the right and be greater than or equal to. Again, that occurs when you divide by a negative number. Now, let's see, a negative over a negative here turns to positive 5/3 x. Negative 9 over negative 3 turns into positive 3. So here is where you're getting your points from. So again, we get our points by going to the y equals. So going to y equals and clearing it out. So y equals clear. Type in 5/3 x, so 5 divided by 3 x, and then plus 3. Again, I'll just graph it to see what it should look like. Since I need 2 points, I'm going to do second graph. So there's a lot of points here that have decimals, right? You can pick any points you want. So there's no reason to pick points that have all those crazy decimals. Just choose 2 points that don't have any decimals. So I will choose -3, -2, and 0, 3. So again, plot those 2 points. So -3, -2 would be left 3 down 2. 0, positive 3 would be left and right 0, and then up 3. Now remember, when you're doing this in math lab, once you put that second point, it is going to automatically connect those points with a solid line, right? You would have to go back later and tell it you want to do a dashed line. But as soon as you plot that second point, it's going to connect it with a solid line, which is actually what I want this time, right? Because it's got the equal to bar. So yes, I do want a solid line. And then I need to decide where to shade it. So let's see. Since the arrow is pointing to the right, that's a greater than, which means greater than means you always want to shade above the line. So greater than means shade above it, not below it. All right, number 3. All right, number 3 just says x is greater than 4. So this one's going to be a little bit different. It's going to be a special line. First of all, there's nothing to solve for because x is already by itself and there is no y, right? If there is no y, that means I can't really go to my y equals in my calculator because there is nothing I can put in that y equals. There's just not a y. So here's how this line is going to look. So let's just, don't even worry about this being a greater than sign right now. Let's just find out where x equals 4. The most obvious place that x equals 4 is on the x-axis on the 4. But x equals 4 actually at an infinite amount of spots. If your x coordinate is going to be a 4, what does that mean? That just means your point is to the right 4. I can be to the right 4 in a million spots, infinite amount of spots. So what does that mean? Let's see. This would be to the right 4, wouldn't it? It's still to the right 4. This is to the right 4. Now, what is changing is my y coordinate because those points are in different spots up and down. But no matter where I am, if my x coordinate, and remember, you can always be looking up there in that top right corner. As long as your x coordinate is 4, that is a point on the line. So it is making a vertical line is what it's making. So now I just need to know whether or not my vertical line that I need to draw needs to be solid or dashed. And since it doesn't have the equal to bar, it needs to be dashed. And I still have to shade because it doesn't say x equals 4. It says x is greater than 4, which means it wants to know where would my x values be greater than this line. There's not an above or below situation here, right? Because it's a vertical line. You can't be above it or below it. You can only be left or right of it. So think about that. Where are your x's bigger than this one? This way, right? Your x's get smaller going this way. Your x's get bigger going this way. So you'd actually shade to the right of that line. That's where the x's are greater than 4. All right, number 4. y is less than or equal to -1. So again, y is by itself. So I can actually go to my y equals on this. I couldn't on the last one because it didn't have a y, but this one does have a y. This one doesn't have any x's, so it's still going to make a special line for the same reason as that last one did. So again, the most obvious place that y equals -1 is on the y-axis at -1. But just like the last problem, all this is saying is that the y needs to be -1. It doesn't care what the x is. It doesn't have anything to do with x, right? There's no x showing. So what does that mean for your y to be -1? What does that mean about every single point? It's gone down 1, right? That's what y being -1 means, is that no matter where your point is, if it's gone down 1, its y is -1, which means you can put another point anywhere as long as it is down 1. It can be on either side. It would just need to be down 1. And you can see that also in your, if you go to y equals, and clear it out, and just put a -1 there, and graph it, look what it's making. It's making a horizontal line, just like these points are making. Right there. And look what happens if you try to find points. If you hit second table, look at every single one of your y's. Every single one of your y's is what? -1. Your x's are changing all over the place because this pretty much says, I don't care what x is, y just has to be -1. Which again makes a horizontal line. Oh, and before I connected it, I should have looked, but this does use a solid line to connect. Now it wants to know where are the y values less than this line. Well, what would less than be? Below. All the y's below this line are less than -1. Oh, is there only 5? Oh, we are going to get to start to review for the test. Sweet. All right, number 5. This one is multiple choice, but what it's going to do is it's going to graph 2 inequalities on the same coordinate plane, the same XY graph. The first one is y is greater than or equal to x plus 3. The second one is y is less than or equal to 2 minus x. So what it wants you to do is graph both of these on the same coordinate plane. Do the shading for each, but the only shading that's going to be in the answer is where they would both be shaded. So let's look at these and graph them on the same coordinate plane. All right, I'm going to graph them in 2 different colors so they'll. So the first one, again, these are both already in y equals for me. So I can just go to y equals, and I'm going to type in x plus 3. I'm going to graph it. Now I'm going to plot some points. So second table, I'll just use these first 2 points. So this first one I'll use -4, -1. And -3, 0. And I'll do this one in green. So -4, -1 would be to the left 4 and down 1. The next one, -3, 0 would mean to go to the left 3 and stay there, right? The 0y tells me not to go up or down at all. And since it does have the equal to bar, it would be connected with a solid line. And where would it be shaded? Y is greater than this line, which means I would shade above it. So there's the first line. Now let's do this second line. So just go back in your y equals and clear it and type in 2 minus x. So that one will be going the other direction. Let's get a couple of points. So second table, I'll just use those first 2 points. So -4, 6, and -3, 5. So I'll use those 2 points to draw this second line. I'll do it in blue. So let's see, -4, 6. So to the left 4 and then up 6. -3, 5. So to the left 3 and up 5. Connect it with a solid line. This one says y, where is y less than this blue line? So here is where y is less than the blue line, is below it. Now, when you are looking at your multiple choice, this one's multiple choice. So when you are looking at your options, the shaded part is only where they are both shaded. Where do they both have shading? Which would be in this part right here, right? That's where there's green shaded and blue shaded. So you want to pick the one that has the shading right there. They all actually have the same 2 lines. The only thing that's different between are the shadings. So the one that has the shading over there on the left, which would be that C right there.
Why are they going that way, Miss Hanson, on this one?
Why are they what?
Why is the shaded area going that way on this one?
On this one, so the blue line that I just drew that goes with this right here, since it is less than, so here's my line. I want to know where the y values would be less than that line. If the y's are less than your line, they have to be below it. So if I'm on this blue line, here's above it, here's below it. So the blue line is actually shaded all below it. But the answer just wants to take into account where it's shaded. Once you've drawn your 2 lines, where is it shaded blue and green? And then here's where it's shaded green is all of this, because the green line was this first one.
Okay.
So this one right here, and it wanted to be greater than this line. So the green shading is above the green line. So there's actually green shading all right here. But again, your answer just wants where there is green and blue shading, which is just this portion of it right here.
Okay.
Okay, now I am going to share my screen and do one more just to go over all the shading processes. Oh, I don't think I shared it. So I'm just going to do number 1. So this one says y is greater than x minus 5. So let's see, where am I going to put my points? Let's see, if I go to y equals, type in x minus 5. And then hit second table to get your points. So I'm just going to pick 2. I'll do 0, -5, and 1, -4. So I'm going to click to enlarge graph. Tell it that I want to draw a line, right? Because you have to come over here and give it your line tool. Once I click the line tool, you're going to plot 2 points. So I chose to plot 0, -5. And remember, up in that yellow rectangle, it'll tell you where you are. So I'm at 0, -5, so I'll put a point there. And then I'll plot this other point at 1, -4. So to the right 1 and down 4. Now remember, as soon as I plot this point, the default makes it a solid line, right? It's going to automatically graph a solid line, but this one needs a dashed line. So if you go over in all those tools where it has the U and the line and the circle and all that, if you go down, this right here, that little thing, it'll be a dashed line. You need to click the button that has this, that has that dashed line, and click it. That will change the line from solid to dashed for you. Now you're going to have to shade. So let's see, what does this say? Y is greater than, which means you want to shade above this line. So how you shade, you see that little paint can? You'll click on that little paint can, and then you just take your your little cursor anywhere above your line and click, and it shades whether you're above or below the line. So you can be anywhere as long as you're above the line and click your buttons. Okay? So we do have 20 more minutes left. So let's get through some of this reviewing for test 1. Because you do have a test due Sunday. All we have left to do this week is review for that test. So we'll start today and then hopefully, keep our fingers crossed, finish on Friday if we have school.
Ms. Hanson, I have a question.
Sure.
What are we supposed to do if we lose power?
That's a good question. So I've already asked this question. So this is, and I asked it, our actual department chair asked Dr. Ellaby, who's our chancellor, if classes are canceled, classes are canceled. Your online instructor can't hold classes. If you have a webinar, which is one of those classes that you just live Zoom all the time, you don't ever come to class for, even though you wouldn't have to drive anywhere, they still can't hold class for that reason. We don't know whose power is going to be on and whose power is not going to be on, right? So
Right.
I'm going to still have the test due Sunday. However, I am not going to, I'm just saying, if you're available and you can do it and you want to knock it out, do it. I'm going to have it due Sunday. If you can't, if your power is out or whatever, I'm not going to try and pick and choose who is saying their power's out just to get an extended time, blah, blah, blah. I'm going to give you extended time, right? I'm not going to try to figure out whose power's out.
So is the test open now?
It's open now,
Currently? Okay.
I think.
I'm saying because I planned on doing it tomorrow. I just didn't know. I know that once I start, if the power goes out, how do I communicate that to you?
You just send me an email. Now,
Okay.
the thing with that, if you do start and the power goes out, I'm not sure what that does. Yeah, your test one is open, so you can take it in at any point. I don't know if there's much I can do besides just give you another attempt.
Okay.
Like if you've done, I think there's 25 questions. If you've done 24 out of the 25 questions, I can probably, I can deal with something like that to where I can send you a problem for number 25 and just plug in your answer or whatever. We'll just have to play that by ear.
Okay, last question.
You've only done a couple of problems and then your power goes out, you might as well just start over anyway.
Right. So do we have to show our work and then submit it to you?
That's another good question.
How do you want that done?
I did that last semester. I'm not going to require you to send me your work. That's in any of it. I have different reasons. I have talked to other instructors, and some instructors make you and some instructors don't. I will, however, if you do work a problem, sometimes you actually get the problem right. Say you have to enter in an ordered pair as your answer, and instead of hitting a comma right here, you hit a period because the button's right next to it. MathLab is going to mark that wrong, right? They're just going to recognize that as a wrong answer. So you would have to email me and show me that you had done that problem and gotten it right and just typed it in wrong. Or for instance, if you type, there's a lot of situations where if you type it in wrong, but you did it right on your paper, this is why I hate MathLab tests. I'd rather just give you a paper pencil test and grade it myself, but I can't do that. So, if you want to argue a question, then I'll just say, well, just send me a picture of that problem and I can go in and give you credit for it. No problem. Okay. Yeah, there's different reasons for me not requiring it. If there, I shouldn't say this out loud. But there's different ways to cheat on a math test. Everybody knows it. Everybody can do it. You can still do that and send me your work. I mean, there's not, that's not, in my opinion, not showing me that you didn't do your own work. Right? So I think for the most part, people are honest and do their work, especially if you're taking another math class next semester and you need this stuff. That's not going to be a good situation for you if you don't actually learn what you need to learn to go further. So I'm not going to require to send work. I might change my mind later this semester, but for this test, no.
Ms. Hanson,
Yeah.
is there a time limit on the test? I know not on the review, but on the
All
regular.
good questions. Yes, there is a time limit on the test.
Oh, wow.
I thought there was also a time limit on the review as well. Isn't that correct?
The time limit on the test is saved right now at 90 minutes.
Okay.
If you feel like you need more time, and you'll know whether or not you need more time once you do the review. The review is the test with just different numbers. So once you do the review, you will know whether or not you need extra time. And that also kind of lets you know if you do the review, remember you can do this review over and over and over as many times as you want, because the grade book is only going to record the highest score. So that's how you know whether or not you're ready for the test and you can complete it in 90 minutes. But I also don't want you to be stressing at the end of 85 minutes with 4 questions left. Okay, so if you keep taking the review over and over and over and you feel like you need more, I would rather give you a little more time and have you work through the processes in your head as long as it takes to do the work right.
How many questions are on a test?
There's 25.
Okay.
Yeah, all good questions. Okay, let's get through a few of these review problems. Like number one. Number one says graph the equation by plotting points. 6y plus 3x equals 6.
That's so crazy. I was just about to ask, don't we have to get the X and the Y by itself?
You're gonna have to get the y by itself. That's exactly right. So we're back to plotting points to graph this line. So yes, you've got to get the y by itself. So the first thing you're gonna do on this one is subtract this 3x. Okay, because we want to be able to go to y equals and put it in. So now we have 6y equals, now these two terms have to stay separate. It doesn't matter who comes in front of the other one though. I always just put my x in the front, just because I like the way it looks. It doesn't matter though. These two terms, they just can't go together because they're not like terms, because one's an x and one isn't, but it doesn't matter who comes in front of the other. I've just got a negative 3x and a positive 6 over here. Divide both sides by 6. So here's my y equals. Let's see, negative 3, 6 reduces to negative 1/2 x plus 6 over 6 is 1. This is what goes to your y equals. Since you're graphing a line, you're going to need 2 points. So going to your y equals and typing in negative 1/2 x plus 1. So remember, you're going to be graphing in math lab, so just make sure what your shape is going to be first, right? You need to, because that's the first thing you're going to have to tell it when you're taking the review and the test, what shape it is. So once you type it in and graph it, you can tell it you're going to draw a line and then pick out 2 points. Just avoid those decimal points. So negative 4, 3. And negative 2, 2. So -4, 3 would be to the left 4 and up 3. -2, 2 will be to the left 2 and up 2. And again, since you've already told MathLab that you're drawing a line, once you plot that second point, it will connect it automatically. All right. Number 2, y equals x squared plus 3. So in this one, your y is already by itself. So you can go straight to your y equals and type in x, then hit your squared button, plus 3. So remember, since the x is squared, this one's not going to make a line. If something's happening with the x, it changes the shape. Okay, so let's remember, go ahead and graph it to see what shape it is. It's x squared, which means it's going to graph a U or a parabola shape. So you would have to tell MathLab that. You're going to click on that tool. So let's get some points. Let's see, I'll do -1, 4. 0, 3, and 1, 4. I can't remember at MathLab, you know, I can't remember how many points it makes you plot to do the U shape.
3.
Is it 3? Yeah, and it could be
Yes, ma'am.
from your XY chart. Any 3 out of your thing in your calculator. So -1, 4 would be to the left 1, up 4. 0, 3. So left and right 0, up 3. And then 1, 4. Here's why it starts mirroring. It's because the y's are starting to be the same. So to the right 1 and up 4. And again, once you put that third point, MathLab will draw your U shape for you. All right, number 3. Y equals the absolute value of x minus 2. So again, the y is already by itself. So let's go ahead and put this in our y equals. So remember, for absolute value, to find those absolute value bars, you're going to hit the math button. Then scroll over 1 to the right to that NUM for number. The very first thing under that is ABS, which is absolute value. So when you hit enter for that, that's going to give you those absolute value bars. So once I have that, then I just put the x minus 2 inside there. So x minus 2. Let's see what this makes. Absolute value makes a V. Now, I do remember this. In MathLab, it's going to make you plot several points on this, and your first point has to be a specific point. It has to be the vertex. Right, good. So it has to be that point right there, which looks like it's on the x-axis, which means That point right there, it's just where the y is 0, right? Because if I'm on the x-axis, you are on the x-axis, that means your y coordinate's 0. You haven't gone up or down, right? So I want to plot that point first. So let's go to second table and see what that point is. Let's see, where my y is 0, that x is 2. That's the first point I am going to plot at 2, 0, 2, 0. And then it's going to say plot any other points you want. So you can do 1 at 1, 1. You can do 1 at 3, 1. You just have to do, the first one has to be the vertex, which is at 2, 0. To the right, 2, up and down, 0. If I'm plotting a point at 1, 1, that means to the right 1 and up 1. And 3, 1. So to the right 3 and up 1. And then it'll connect them to draw that B. All right, we still got a couple minutes, so maybe we can get through number 4 and number 5. Number 4 says determine whether the correspondence is a function. So remember what the definition of a function was. That's a correspondence or a relationship where each element in the domain only corresponds to one element in the range. So if each element in the domain just goes to one element in the range, then it is a function. So here's your domain. It is -1, 1, and 8. Here's your range. 2. But look at each arrow. Here, the -1 only goes to 2. It only goes to one element in the range. 1 also only goes to one element in the range. 8, same thing. It also only goes to one element in the range, right? So each element in the domain only traveled to one element in the range. So yes, this would be a function for that reason, because each element in the domain corresponds to exactly one element in the range. Okay, number 5, and the last one that we'll do today, is a plug and in problem. It gives you a function. It says f of x equals 3x squared minus 4x. And it wants you to find 3 things. It wants you to first of all find f of 0, which just means go to this function. Everywhere you see an x, you're going to put a 0. Right? We've done a lot of this. So I have 3 times 0 squared minus 4 times 0. What's that all going to end up being?
0.
0, right? Because if you square 0 and then multiply it times 3, you still have 0. Minus 4 times 0. That's all just 0. Then it wants you to find f of -1. So again, replace the x's this time with -1. So you have 3 times -1 squared minus 4 times -1. Do your exponent first. This is where most people, if you're going to make a mistake, it'd be right here. -1 squared is +1. So this really says 3 times positive 1, which is positive 3. Negative 4 times negative 1 turns that to positive 4. So you're left with 3 plus 4, which is 7. And the last part, f of 2. So same function, just replace the x's with 2. So I have 3 times 2 squared minus 4 times 2. So again, do your exponent first. You can't multiply here until you've done that exponent. 2 squared is 4. So this really says 3 times 4, which is 12, minus 4 times 2, so minus 8, which gives me 4. Okay, so we will stop there. Hang on. All right, I got Ellis, Hauser, Acker, Todd, Sharonda, Ellis, Hines, Grant, Morrison, Peak, Brescia, okay. Y'all are good to go. I'm going to start the support for 3.7 here in just a minute. I'm just going to end this one so there'll be separate videos.